When you're solving limits algebraically, the very, very first thing you always want to try is direct substitution. Because if you use direct substitution, which just means plugging in the x value in question, if you do that and you get a numeric value, you're done. You've found your limit. If you don't get a numeric value, like if you get 0 over 0 or if you get infinity, something like that, well, there's other strategies to try. And I've got a limits flowchart for that and also videos with those more complex strategies. But for now, let's just look at direct substitution. The example I have in question here is the limit as x approaches 2 of the function x plus 3. What that's really asking you is, where is the graph of f of x equals x plus 3 going as x is approaching 2? So all we have to do is replace the x values with a 2. So the limit as x approaches 2 of x plus 3 is equal to 2 plus 3, or 5. Piece of cake. Graphically, what that means is, here's 2 on the x-axis, as x gets closer and closer to 2 from each side, our graph is getting closer and closer to 5. The y values of the graph, that is. It's getting closer and closer to 5 from each side. So our limit, as x gets closer and closer to 2 from each side, f of x gets closer and closer to 5. So you don't need a whole lot of practice on these. Again, this is the very first thing you should try anytime you're doing algebraic limits. I have a few examples here for you just to show you how simple this really is. This first problem, we're looking at the limit as x approaches 4 of a quadratic, x squared minus 2x plus 5. So really, all you have to do is plug in that 4, so 4 squared minus 2 times 4 plus 5, 16 minus 8 plus 5, and that gives us 13. That's our limit. Next one, the limit as x approaches negative 3 of the rational function x plus 2 over x plus 6. That's just negative 3 plus 2 and negative 3 plus 6, and that gives us negative 1 on top and 3 on the bottom. So our limit is negative 1/3. The last two are trig examples. Limit as x approaches pi of cosine of x. That means we can plug in pi for x. And what is the cosine of pi? Well, if you know your unit circle, you know that the cosine of pi is negative 1. If you don't know your unit circle, check out my video on that. It's on my website. And then finally, the limit as x approaches pi over 4 of tangent x. We're literally just going to say what is the tangent of pi over 4, and that, of course, is 1. Again, if that doesn't make sense, check out my videos on the unit circle and trig functions. So if you try direct substitution and you get a numeric value like we did on the examples above, then you found your limit. If you do not get a numeric value, you need to try some other strategies and to determine whether that limit actually exists. And of course, I have a flowchart and other